Hi everyone, this is Miss Jennifer from the New Haven Free Public Library, here to do another kitchen science video with you. I hope you all had fun with our last video. This week we're going to be making a homemade lava lamp. So lava lamps were actually a decorative lamp that were popular in the 70s and 80s. We're not going to be making a true lava lamp, like ours doesn't have a light source. But basically, lava lamps had these different colored pieces of liquid that looked like thick lava that would heat up and bubble to the top and then sink back down. So we're going to be doing a project that gives a similar, though not exactly the same results. So how do real lava lamps work? That's the first thing that we need to know. You're going to have two liquids of very similar density, and we're going to talk about density in a minute. And they are insoluble to each other. So insoluble is a big word that essentially means they do not mix. Heat is added to the bottom of the lava lamp, which is usually just through a light bulb. And then the heavier liquid, or the more dense liquid, is going to heat up. And as it heats up, it expands. And because it expands, it becomes less dense because it's now taking up more space, and it rises. But as it rises, it cools down. And when it cools down, it contracts, which means gets smaller and then sinks. And this process is repeated over and over and over again until the lamp is shut off and cools down. Lava lamps can get very, very hot. So density. The image that you're seeing is a smaller version of a project that we did when the library was still open, called a density tower. If you can see the different colored liquids, they're all different types of liquids. I'm assuming that the one on the bottom is water, the middle is oil, and I'm not sure what the one on the top is. Probably something like rubbing alcohol. So density is a word that we use to describe how much space is in an object, how much space an object or a substance takes up. So that's its volume. And there's a funny story about how volume was tested, is they filled a bathtub all the way up to the top, but had a person get inside of it, and then they tested the amount of liquid that came out of the bathtub, and that was the volume of the person. So yeah, a volume is how much space an object or a substance takes up. And then that is in relation to the amount of matter in that object or substance. And matter is, it's kind of just like the amount of stuff in it. In this case, it would be like atoms and molecules, but it's the amount of stuff in it, which is called its mass. And the fun way to remember density is by thinking, I love density. Because if you draw a heart and then draw a horizontal line through it, it looks like an M over a V. So we love density. That's a great way to remember this formula. Now let's talk a little bit about Alka Seltzer. Alka Seltzer is something that we're going to be using in this experiment, and it's unique in that it is both an acid and a base. So if you remember our last science experiment that we did making the lemon juice and baking soda and endothermic reaction, Alka-Seltzer does this, but by itself. So it contains sodium bicarbonate, which is baking soda, which is what we used as our base in the endothermic reaction experiment. And it contains citric acid, which is found in lemon juice, which we also used in our endothermic reaction video. So when you put an Alka-Seltzer tablet in water, it starts to dissolve, and then the sodium bicarbonate and the citric acid mix and form carbon dioxide. So let's talk a little bit about the science behind our homemade lava lamps. So water is more dense than oil, which means it's going to sink to the bottom. And on top of that, oil is hydrophobic. It means oil and water do not mix. Oil does not like water at all. Alka-Seltzer reacts with water to form carbon dioxide. So when we put the Alka-Seltzer tab in, it's going to sink to the bottom because it is also more dense than the oil, and it's going to react with the water and start forming those bubbles. The carbon dioxide and the water molecules are going to stick together, and they're going to start to bubble up to the top because it is less dense than the oil. When the carbon dioxide and the water pairing reaches the top of the bottle, the bubble is going to pop and the water is going to sink back down to the bottom. So what are you going to need to do this project? You're going to need a clean, clear bottle, preferably with smooth sides and the label removed. The reason that we're suggesting a bottle with smooth sides is because if the bubble hits the side of the bottle that is indented, it might pop and you won't get the same reaction with the experiment. I'm using a 1 liter clear water bottle that I removed the label from. You can use a 2 liter bottle, a 16-ounce bottle. You could even use a large a large jar of salsa or something like that. The only difference is going to be the larger the size, the more vegetable oil, water, and Alka Seltzer you'll need. You're going to need vegetable oil, you're going to need water, and you're going to need a couple Alka Seltzer tablets. Now, food coloring is optional, but I would highly suggest using it if you have it. This will really make it easier to see what's going on. All right, guys, so let's get started and do this experiment.
All right, so now that you see all the materials that we need, we're going to start out by actually showing you the difference in density. So this is a 1 cup measuring cup. I'm going to put it on our scale, and right now it says 44 grams, and I'm going to push the on button, and that's going to 0 it. So now you can see it says 0 grams. And I'm going to fill up this 1 cup measuring cup all the way to the top with vegetable oil. All the way to the top. All right, so that is full. This is 211 grams. So I'm going to rinse this cup out. And then what I'm going to do is I'm going to fill the same cup with water, and then I'm going to show you how much it weighs. All right, so we've poured the oil into here and cleaned out this. You can see again it's at 44 grams. So we're going to 0 that, and then I'm going to fill this with water all the way to the top. Not all the way to the top. Now, if you remember, the oil was at 211 grams. The water for the same amount is 232 grams. So that's showing you that there is more in the water than there is in the oil, even though it's the same amount of liquid. All right, so now we're going to actually get into this project. Oops, I spilled a little bit. So you're going to take your bottle that you've cleaned out. This has a little bit of excess water in the bottom, but that's okay. And what we're going to do is we're going to fill it up about 3/4 of the way with oil. So this is the oil that I used before to show you the density. So that's 1 cup. We're probably going to need 3 cups of oil. So the important thing to remember when you're doing this is that the different size bottles are going to need more or less oil. Okay, that's good. And now, so you can see all of the oil's done, we are going to pour in our water. Now I have a giant funnel, but that's okay. And you're going to want to leave a little bit of space at the top of the bottle. So you don't want to fill it all the way up to the tippy top. There. Right. And we're going to let this settle, and we'll come back in a couple minutes. All right, so this is settled, so now you don't really see a ton of bubbles, so that's all I wanted to make sure that you could see. So now food coloring is optional. But if you look at this, you can see there's a distinct layer of water and oil. When you put the food coloring in, food color is water-based. So I'm gonna put in about 10 drops. And look, it's sinking through the oil. Because remember, oil is what? Hydrophobic. That's right. So it's sunk through the oil. I'm going to screw the cap on. And then I'm just going to shake this up a little bit. So now the blue food coloring is going to mix with the water. And then it's going to settle again. It's just going to take a minute. And once that's settled, we'll show you what to do next. All right, so this is settled pretty well. I mean, it's not quite all the way done at the bottom, but I think it's good enough. And you can see this distinct line again at the bottom with the blue water and the rest of its oil. The next thing we're gonna do is we're gonna take, this is an Alka Seltzer tablet. I have 2 of them. It's very important you don't get these wet until you're ready to start, because then it'll ruin the reaction. So the first one I'm gonna do, I'm gonna put the Alka Seltzer tablet in and then put the top on, and we will see what happens. But if you notice, this isn't going to fit. So we're going to break it in half. And we're going to put all our pieces in. And we're going to put the top on. Oh, and there it starts going. Now you're just going to wait for the whole tablet to dissolve. And once it does that, the bubbles will stop. So as you can see, like we talked about before in the PowerPoint, is the carbon dioxide is mixing with the water, which has been turned blue, and the blue bubbles are going up. The carbon dioxide is getting released at the top, and then the bubbles are sinking back down. It'll probably go for another 30 seconds or so. And you can already see that it's slowing down. All right. So now we're going to do this one more time, but this time we're going to leave the top off. Ooh, I took the top off. And it's bubbling back up. All right, let's leave the top off and see what happens. That is bubbling a lot more. Why do you think that is? I'm not sure, but I can find out for you if you wanted to know. Now, there are other ways you can do this. You can put glitter in this. You can use different colors. I just use blue because it's easy to see. It's really fun to do if you have glitter at home. You could do pink. You could do purple. You could do orange, so it really looks like lava. And you could do a whole bunch of them. So basically, you could keep doing this for as long as you wanted. As long as you have Alka Seltzer tablets, it will keep working. You just have to keep putting more and more in, and it'll keep going. All right, everybody, so that's the project that I have for you today. I hope you had fun, and I will see you soon.